Greetings! This week we're focusing still on third grade. We're focusing on measurement and data and geometry since they're pretty close related. Let's take a moment to go over the measurement and data cluster here. There is a lot going on. I'm not going to read it all because we're going to go through the majority of the different types of problems at these in case within the next few slides. So take a moment to read through them. There is a lot here, but if you've probably noticed at this point by going through standards, there are many questions or problems that we bring up or discussion that we talk about, and it covers more than one specific standard. It crosses them. So keep that in mind that although there's a bunch of individual ones, there are many things that we can do to help students that cross-relate one another together. Further, cross-relates more than just one cluster. So it might cross-relate measurement and data with geometry, or geometry might go in with operations and base 10. So keep that in mind as we go through these. The Robotics Club is having a robot race. They raced 4 of their favorite robots to see how fast they can move. The race started at 12:55 p.m. The times on the chart show how long it took each one to reach the finish line. Find the time each robot finished so it can be written on the trophy. So it looks like the pink robot finished in 16 minutes, the orange robot in 21 minutes, the blue robot in 12, and the green robot in 27 minutes. Some questions to think about, something that you might ask your students or you may be thinking about yourself. What is the task asking us to do? What information do we have? Do we need more information? Is there more than one solution? Can you explain your solution? How can you tell which robot was first? What strategies and tools can you use to show the finish times? How can we use a number line to complete this task? So the race started at 12:55 p.m. So I have a number line here, and notice that I start my number line right here at 12:55. And then I've got a red benchmark of 1 o'clock. And notice that it is broken into smaller benchmarks of 5 minutes in between. So let's start with the pink. They finished in 16 minutes. So if they started at 12:55, we could jump 5 minutes to 1, 5 minutes after 1, 10 minutes. So we've gone 5, 10, 15, one more to make 16. So I see on my number line that that equates to 1:11 p.m. When I look at the orange robot, I can just go off of where I just finished with my pink one. If I went 5 more to get 5, 10, 15, 20 minutes, then I just need 1 more minute to reach 1:16. The blue robot, however, finished in 12 minutes. So we would need to go 5, 10, plus 2 more to get 12. So this would be 1:07 p.m. The green robot finished in 27 minutes. So we need to count by fives, 5 minutes, 10, 15, 20, 25, 26, 27 for 1:22 p.m. Why would we begin counting by fives instead of ones? If you think about that for a minute, it makes more sense because we have a long distance to go and it's easy to count by fives on the clock. We certainly could count by ones, but it would take us a while. And sometimes we don't necessarily want the quickest way, but the way that makes the most sense. And did you notice any patterns as you were going along? This activity shows us that time can be measured, and that time represents the duration of an event from its beginning to its end, no matter what time it starts. The robot race trophies are ready to be awarded. Each one should show the fastest finish time from a race that color robot won. Write the time from the number line on the clock on each trophy. Explain how you determine the times on the number line. Take a moment, pause the video, complete this activity, come back, and let's talk about it. Okay, I got 3:37 p.m. from the number line below above. I see that we have the 3 o'clock benchmark. I see that we are past the smaller benchmark of 35, and I go 2 more spaces to get to 37. For the gold one, I see 4:14 p.m. So I see the 4 o'clock benchmark. I can go the 5-minute, 10-minute benchmark, and then 4 smaller spaces plus 4 more to get to 4:14. And finally, the pink one, I get 4:49. I'm still slightly past the 4 o'clock, but not quite to the 5 o'clock benchmark. I am past 4:45, but not quite to 4:50. So I count 1, 2, 3, 4 to get 4:49. It usually takes Erica 45 minutes to do her homework. If she starts her homework at 5:30 p.m., what time will she finish? One day, Derica started her homework at 6:45 p.m. and finished her homework at 7:20 p.m. How long did Derica spend on her homework? Another day, Derica finished her homework at 5:05 p.m. after spending 40 minutes on her homework. What time did Derica start her homework? Work through these elapsed time problems using an open number line. Pause the video, see what you can do, and come back and we'll talk about each one individually. So when I look at the first one, it takes Derica 45 minutes to do her homework. She started her homework at 5:30 p.m. So I start my open number line. Recall that an open number line doesn't have tick marks listed. We create them as we need them to kind of keep track of where we're going. So to get from 5:30 to 6 o'clock, a benchmark, I need to add 30. But I haven't quite elapsed 45 minutes. I still need 15 more minutes. So if I go from 6 o'clock, 15 more minutes would bring me to 6:15. 30 and 15 gives me 45 minutes. Therefore, Derica will finish her homework at 6:15 p.m. One day, Derica started her homework at 6:45, and you can see that I have a typo here. Here we go, fixed it. There we go. Started her homework at 6:45 p.m. and finished her homework at 7:20. How long did she spend on her homework? So to get from 6:45 to the benchmark of 7 o'clock, that's 15 minutes. But we still need to go to 7:20 because that's what time she finished. So we need another 20 minutes to get to 7:20. So overall, when I count how many minutes have elapsed, 15 plus 20 gives us 35. So Derica spent 35 minutes on her homework. So another day, Derica finished her homework at 5:05. After spending 40 minutes on her homework, when did she start? So remember, it's elapsed time. So we finished at 5:05. So we need to work our way backwards to find out when we actually started. So from 5:05 to our 5 o'clock benchmark, we subtract 5 minutes. But we need to spend 40 minutes. So we've only done 5 minutes so far. The next benchmark would be 4:30, a nice benchmark. So 30 and 5 is only 35. We still need 5 more minutes. So if I subtract 5 more minutes from where I started, it should be 25, we get 4:25. Therefore, Derica started her homework at 4:25 p.m. Yummy Nut Company needs to weigh these items before mailing. Cashews are 396 grams, licorice is 503 grams, and almonds are 454 grams. Use base 10 pieces to find the correct total and to help explain your answer. Using one of our virtual math manipulatives, I put up a thousands, hundreds, tens, and ones chart. I've also included our base 10 pieces so we can put together, we need to find out how much total they all weigh together. So when I'm talking about in total weighing all together, that means we need to add them. So I know that cashews are 396. Cashews are 1, 2, 3, and 96. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I need 6 ones. 1, 2, 3, 4, 5, 6. Okay, licorice is 503, so I need 5. 1, 2, 3, 4, 5. I'm sorry, our work mat's getting kind of 0 10s and 3 1s. And we need 454 almonds. 1, 2, 3, 4, 5 10s, 2, 3, 4, 5, and 4 1s. 1, 2, 3, 3, 4. 1, 2, 3, 4. Okay. For the sake of cleaning this up a bit, typically we would work our way from the ones column all the way to the thousands column in order to simplify, but I want to try to get rid of some of these hundreds here. So I'm going to count out 10 hundreds makes 1 1,000, so one group of 1,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That cleans it up a little bit here for us. Oops. So there's 2 of them here. Okay. Even though, yeah, they're linked too. Okay, so now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that I can exchange for a one group of 10 here. I don't have any more to do that again. So now I need to do the same with my 10s to make a group of 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So now I have one group of 1,000, 3 groups of 100, 5 groups of 10, and 3 ones, for a total of 1,353. So I have the same question here, except this time let's use a number line to find the correct total and to help explain our answer. Deconstructing numbers will help us to add more accurately and more quickly on a number line since we don't have individually. I can see that they're also going by groups of 100, so 0 grams, 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. I can rewrite 396 as 300 plus 96, 503, which is 500 plus 3, and 454 as 400 plus 54. So notice I separated the hundreds group from the tens and ones, and I'll show you why here in a moment.